Years ago, when I offered the first time database design, so this is done for your semester. I actually covered only the designing part throughout the semester, but many of the students complain it's too easy. So, however, database design is not the main. It's the main part of the database related topic, but it's not all the topics that you can find from the database, the area. So actually, 10, 12, 13 years ago, when I was in my hometown, because I'm from South Korea. So at that time, I was the database administrator. Okay, I managed the 100 server, which is quite big at the time, and also there exists more than 20 database instances. So I managed such a database. So that with the supervisor, my manager, so only 2 people manage the database server in a bank at the time. So I managed the Oracle database, and from the 6.3, 4, then 7, 8, 9, 11, but not much different, and the DB2, and also Infomix, because my company was merged with a little bit bigger bank at the time. That bank used the Infomix database for the database server. And also when I moved to the IBM, so at the time IBM had definitely DB2 for the database server. They tried to use it. So I have experience to use all 3 major the DBMS system. Unfortunately, I didn't satisfy at the time. Whenever I encounter problem on the database system, I was curious. If I submit the query, what happened? Okay, have you ever curious about such a thing? No. So also sometimes, many times actually, every time the developer complain why my query is slow. When they test it, it works very well. But when they apply to the production server, real server, it's slow. Also getting slow. Then what makes such a problem, performance issues? So I was very curious, but nobody taught me. So at the time I decided, what if I build my own database system? That was the motivation why I decided to quit my job and move to United States to get a higher degree. That's my biggest fault in my life. So nowadays, in terms of salary, my friend or the colleagues who have worked with me, their salary is much better than professor. But anyway, they still work almost 6 or 7 days a week. So work hard. So anyway, so database system, definitely first you need to design and create and access use such a database system for fast query. However, sometimes you want to see what's going on inside the database system. Also specifically the DBMS system. The rest of the semester we will discuss about how the DBMS, database management system, is working in terms of the theoretical approach. So we are not going to test or exercise directly. Instead, we are going to see what kind of algorithms are used to run such a database management system. So eventually, for the project, the second part of the project, you are going to implement query optimizer. Okay, so simplify the query optimizer to get more experience about the database. The first topic is a query optimizer. So what is a query optimizer?
It's something that will make the query run more efficiently.
Efficient. That is the most important part of why we are using the database management system, right? So somebody may argue the most important thing is the security, or the something maintenance issue, or the something other. But in my opinion, one of the biggest reason and most important reason why we are using the DBMS system is we want to access the data very fast, efficiency. Okay? Then how can we make the DBMS system efficient to access the data? Actually, sometimes the Professor Lee mentioned about if you are using the database system or join, one of the questions in your exam, midterm exam, is asking about what is the characteristic or not characteristic of the join operation. Join, actually, it's a very expensive operation. It's getting slow, right? You need to access this table, you need to access this table, you need to combine and compare and select the data. It will take a longer time. So I mentioned about the disadvantage of the database management system comparing to file system. File system is faster sometimes. Okay, you can directly access the file, retrieve the data, and return the data. Just print out, or you can use such a data in your application program. Comparing to the DBMS, you need to access the DBMS system. It will take. So then, how can we make the DBMS system faster, efficient system? There are two main parts. One is memory. What is the memory? I think is there anyone who are going to take who is taking the operating system here? What is the topic of today's lecture in operating system? You forgot? The memory management. Okay, it's a chapter 8. So we are going to talk about the memory. So what is the memory? Nobody did this part in operating system class. Right? So what is a memory?
You store data.
You store the data? Do you like the bigger memory or smaller memory?
What type of memory?
Bigger memory. A type of memory, yes, bunch of different types of memory, but the bigger is the better. The problem is? Slow?
No.
It's faster than the other storage, like comparing to your hard disk drive. It's definitely faster. So that is the reason. Actually, we had what is this?
Computer.
It's a computer. It has the CPU. Okay. It has the hard disk drive. In your hard disk drive, you have the data like the program. Okay. CPU need to access such a data, sometimes the instruction, right? Can CPU directly access the data from the hard disk drive? No, why?
Two different speeds.
Different speed. It's too slow, okay? You cannot get the benefit of the CPU speed, 2.5 gigahertz or the 4 gigahertz. So which means within a second it will be the 4 gigatimes of the CPU cycle. So sometimes one cycle you can process one instruction, right? But you cannot get such a benefit of the CPU speed if you directly access the hard disk drive. Then how can we address? We can put something in the middle as a cache area. What is a cache? It's a frequently used, so instead of the requesting every time, we try to keep the data that has been accessed in the cache, then we access. This is the memory, and it's used for cache to reduce the gap of the speed. Okay, who proposed such a computer architecture? Bill Gates? Older. Von Neumann. It's called the von Neumann architecture. The memory is in the middle, in between CPU and storage, permanent storage. What is the other? Yeah, other architecture. Why don't you search Google or Wikipedia? There's another architecture that CPU can directly access the memory or the hard disk drive, which is not frequently used. It's either Harvard, MIT, but I forgot. Okay, So there is something other. But most of the computing architecture nowadays is a whole Neumann architecture. It has the main part of the whole Neumann computing architecture is we can put such a memory. It's not just memory, it's still slow comparing to the CPU cycle. We have even memory in the CPU. So L2 cache. Okay? Even that is the cache to reduce the gap between this one CPU and the memory. Okay, so similarly, we can get the benefit of the cache in the database system. How can we use? So, for example, I access the data from the hard disk drive, which means the database. Okay, then why don't you put such a retrieve the data in the memory? That one is a cache actually, but in terms of DBMS, it's called buffer. So we use the name of buffer. So we can use the buffer as a cache. So put any data, retrieve the data in the buffer. Next time, if somebody read this data again, we are not going to access the hard disk drive using the buffer. Okay? So that is a reason. When you install the DBMS, Oracle, is there anyone who installed the Oracle server on your laptop or any computer? Nobody? Why don't you try? Then they ask at least 4 GB memory.
No.
Once in a semester. Today is my daughter's birthday, so my relative from Hawaii, because Hawaii is in the morning. So my elder sister lives in Hawaii. So even that is harder. So my parents lives in Korea, so it's okay too, because it's just exactly 12 hours difference. So in the morning, there's the evening is the morning, so we can communicate. But Hawaii is 5 hours, 6 hours, depending on the daylight saving time. So it's very hard to communicate, even hard to see. Really, because it takes almost 12 hours, 10 hours from day. Anyway, so we can use the buffer memory. So we can, when you insert the Oracle database, it suggests at least 4 GB memory because of that. Okay, so that is one of the ways to speed up the DBMS system. That is called the buffer management. We are not going to see the separately for the buffer management, but from time to time I'm going to introduce about how to manage the buffer using the LRU algorithm or something like that. The second part, to speed up the DBMS. Anyone can guess how can we make the DBMS speed up, efficient system? When we access the data, when you look up any information using the textbook, what is the best way?
Sorted index.
You can use index. Same thing. When we access the data, we can use indexing data structure. So, what is an index? It's a data structure. What kind of data structure? It's a sorted data structure. Okay? To speed up, to retrieve the data. There are a bunch of different indexing structure. Okay? But in database, we mostly use the B3 index or B plus 3 index. When we are saying B3 or B plus 3, this is not the balanced tree. This is not the binary tree. It's a balanced tree. We will learn about this tree structure. The chapter, I forgot the name. Anyway, it will be in the main part of the rest of the semester. Yes.
Every indexing structure is sorted? Not necessarily.
It depends on what is a sorting. Okay? Sorting is an alphabetical order, but it can be, for example, we can sort the data by using tree. Okay?
I know, but for example,
Yeah.
like hash table is an indexing structure.
Yes, it's based on the hash key. We can sort the data by hash key. Then, if we, so it depends on the definition of the sort. Okay?
Okay.
So sort means in general. Okay? So reorganize. Okay? That's a good question. And anyway, so there are two main approaches to speed up the DBMS system. There is another one. Okay? There is another one. It does not directly speed up the accessing the retrieval time. However, it will affect, okay, affect to find to the retrieve the data, okay, total amount of time to retrieve the data. That is query optimizer. Okay, so for example, I gave you the example of the such a query optimizer. Probably the first half of the semester, like when you travel from Bridgeport to the Manhattan, how many different ways? Many. What is the best way? Fastest way? Motorcycle. Okay. So you can imagine bunch of different way to travel to the Manhattan. So mostly you like to select the fastest way. Okay. Sometimes such a fastest way. So if you are using the motorcycle, but what if the I-95 is blocked? Okay. So nobody knows. So what is the best way? You can check the Google every time. So what? So you can build a certain rule. Okay. So like depending on the time. So rush hour 7 to 9 o'clock. We are not going to use the Mary Parkway or nor the I-95. Instead, we can use the chopper. If you are rich. So you can imagine bunch of different way to go to the Manhattan. What about the database query? Database query is the same thing. Okay? For example, the midterm exam, one of the exam question was to join the 3 tables. Okay? Think about such a joining 3 tables. Select from where and this is a selective selection condition. A dot ID name or date January 1st, 15. So do you think how many different ways to access such a data? How many different ways? So you can consider ABC as a city name, okay? And or the join condition is connected the highway, something like that, okay? How many different ways to travel A, B, and C city? First, you can consider the order of listing city first. So you can travel like the C, A, B, or C, B, A, or B, A, C, right? It's different. So how many different ways? 6? 9? 6? It's the problem of what? It's a factorial, right? It's a factorial. Okay. So in case you have the 3 cities, so 3 factorial. So 6 different ways. Then when we access each city, okay, there might be different entrance, the highway, okay? For example, the Connecticut has I-84, also Mary Parkway, and the 95, and the 91 from the Massachusetts, something like that. We have the different entrance. So let's say each one has 5 different highway to access to enter the city. Okay? Each one has 5. How many different ways to access A? 6 times. For each case, 5 times, 5 times, 5. 5 times. So 125 times 6.
That's
Easily several. It's how much? 705, 750 different cases. Okay? But you need to select one of them. Which one? Fastest one. Okay? So, for example, when we access the A, I-95 is the fastest one. So using I-95, so first go to the A, then when you go to the B, so we use the I-91 and so on. So we try to find the fastest way. Okay? It's the same thing in database. When we access the table A, B, and C, that is different from the C, B, and A. So I gave the extreme example. Okay? Let's say we have the 10,000 students. Okay? I gave the example of the interview between the military soldier and the parents. So we have, for example, the 10 parents in this room. There are the 10,000 the soldiers who are waiting for their parents, the other room. What is the best way, fastest way to match that? So first, for each parent, we can ask who is your son or the daughter. Then find that son or the daughter from other room where the 10,000 the soldiers are in there. Okay? Because the name or the ID is unique. Okay? Then we can easily find. However, if you go to the room where there exists 10,000 students, 10,000 people or the soldier, for each the soldier ask who is your parents. Then match how many times? 10,000 times. It will take much longer time. Even though output is the same, it will be totally different performance. That's the idea. So among these 1,000 different ways, we try to find the fastest way. That is the goal of objective of query optimizer. So query optimizer will select one of the fastest way. Then how can you decide this one is the fastest way? So when you travel to the Manhattan, what is the fastest way? You need to check the Google. Okay? Shortest time, right? It's a similar actually. So when you access the data, so think about what criteria is the most expensive operation?
searching.
Engine search, this one, hard disk drive. Eventually, we need to access the data, okay, here, because it's a database system that we design and that we created. So eventually, we need to access the data here. So this one, in other words, input and output, I/O. The number of I/O determines 99% of your access time. There exists a small amount of the seek time and latency, but we can ignore. Even we can consider I/O, number of I/O in memory, but that's comparing to the number of I/O in hard disk drive. It's just quite small. Almost we can ignore. So when we determine which one is the fastest one, how can we decide? Number of I/O. Higher the better? No. The less number of I/O. Okay? We will select the path or way to access the data that require least amount of I/O, input and I/O. That is our goal. That is our objective. That is the goal of query optimizer. So in your project, so you will calculate the number of I/O for each case and select the least amount of I/O, the query. Okay. Then, how do you know number of I/O? You need to run each and every case. thousands of times? No, it's not possible. It will take forever. So when you make the plan, okay, to travel Manhattan, do you want to ask your friend, you go to the I-95 and inform me, you go to the Merritt Parkway, you go to the Port Jefferson and the travel Long Island Expressway? So you cannot do that. Instead, you can get the help of Google. Google has the experience, the prior data. So based on the experience, prior data, they can best estimate the time. Similarly, when we access the data, we need to something prior, the knowledge, the prior information. When we access the table A, how many input and output, how many IOs are required? When we access the B, how many? It's the best estimation. To do that, we need to keep such a statistical information. Okay? For example, A has 1 million of the data, and B has the 10 tuples, 10 data. C has the 10,000 tuples. Each tuple is 10 bytes. This one is the 100 bytes, something like that. So if we have such an information, we can have best guess. It's educated. It's not random guess. It's an educational guess, statistical guess. So we can guess number of IO instead of the testing real, the query. Okay, that is the main rule of query optimizer. Which means we need to have such a statistical information before we run query optimizer, right? So is there anyone who saw the project B description? Nobody? If you take a look at the project B1 and B2, what is the main part? What is the main goal of B1 project? First part of the project B is the creating catalog database. So you need to keep such a statistical information for each table, for each index. If you are traveling to the Manhattan, you need to have the information about I-95 along the time, and the Merritt Parkway, and the MTA schedule, everything. Where you keep such information? In your database. So it's the same thing. So statistical information should be created before you run query optimizer. That is in the catalog database. So catalog database is a database to manage the metadata of your database system that we have learned in the beginning of the semester. Okay, so that is the first part. Then we need to implement such a query optimizer algorithm. That is the second part of the project B that we are going to discuss from now on. Yes?
Is it possible to get the number of I/O operations from the API?
Probably yes.
So it's easy then.
It depends on the DBMS system. Okay? Oracle provides such a statistical information API through what? SQL. You can select such information.
Okay.
But in our project, we will create our own catalog database. Okay? You will manage your own statistical information. You are not going to use existing the statistical information. Okay? So you will implement your own the statistical data and the catalog database. Okay. Any questions? So that is the goal of the query optimizer. And first, so everybody use the SQL Plus application in the exercise lab and for during your project. Then what happened when you submit the SLAP SRS from employee? It's a SQL. What happened? It will retrieve the data, right? So it's a name, ID and the data and retrieve. In between that, what's going on? First, this is the application program. It's a command line interface. What does that mean, command line interface? Whenever you submit the SQL, it will be compiled line by line. That is this one. Semicolon means it's the end of the SQL, and please the process this one. So if you submit your SQL with the end of the semicolon, which means you submit the data, then something happened in your the server, database server. So what's going on? First, this one should be compiled, because SQL is high-level language, which means it's close to human being, like me, like you. Unfortunately, such a high-level language is not close to computer, DBMS. It should be compiled to the machine code or the binary code, something like that. So this kind of the compiler is called interpreter. Okay? What is an interpreter? What is the main difference between interpreter and compiler?
Interpreter will translate the bytecode to machine language, and the compiler will translate the syntax to the bytecode.
Actually, both of them compile. Both of them convert
Yes.
the high-level language to machine language.
Compiler converts every time, but interpreter converts line by line.
So compiler is for entire source code, okay, language, entire source code. On the other hand, the interpreter is line by line compile. It's actually both of them are compiler, but interpreter is the line by line compile. So SQL Plus follows such a interpreter. Okay, so this one will be submitted, then it follows the same procedure as the compiler. Scanning, parsing, and validating. Scanning means scan. So if you go to the airport nowadays, so some selected man and woman will be scanned by the something machine. So just like that, your source code will be scanned whether syntax is correct or not. Okay, scan. Then parsing means sometimes this query may have if you are using the PL/SQL, it has the variable, right? So it can be parsed. Then finally, whether even though this is correct in terms of the syntax, I do not create the employee, right? So employee is not my table, should be error. So during the validating, it will check whether this user has the permission to access data or whether there exists the table in the database one. So it follows it's just a general the step of the compiler, scanning, parsing, and validating. Then this will be converted to the binary code, binary form. Or sometimes it's called the P code or the immediate form of the query. Okay, it will be converted that close to the computer, DBMS system. So if you see such an immediate form of query, nobody can understand. But computer, query optimizer can understand that. Query optimizer, because it's a path for the syntax or the compiling step, and find the fastest way. Using what? Catalog database information. Okay, using Google information, traffic information, find fastest way. Just like that, we will find query optimizer find one fastest way. What is the form output of the such a query optimizer? What is the output of the Google Map? It shows the plan of your trip from your home to Manhattan. So take right turn, left turn, in exit 35 or whatever. It's just plan of your trip, like the execution plan. It shows the plan of execution. Like first you need to access table A. Okay, join with the B using the join ID, and also you can use the index of the ID then join with the C, something like that. It shows the plan to access the data. That is called the execution plan. Based on execution plan, the DBMS process then access the data. At that time, if the data exists in the buffer, you don't have to access the hard disk drive. Instead, you can return the buffer cache data. Otherwise, you need to access such a data. Then finally, you can get such a data. So there are a lot of things happen in the middle after you submit and when you get the result. Okay, that we are going to see that throughout the semester. Any question? So how can the query optimizer process the submitted query? First one, the query optimizer cannot process the query simultaneously, which means how many plans can you submit at the same time? It's only one, but it will show different ways. If you wanna make another trip from Manhattan to the Philly, it will be connected. Okay, so just like that. Sometimes one query is a correlated query. There exists two select from where. So query optimizer separate. So each one means the query block. Each block has one select from where, one select from where. Okay, so make the different query block and process differently. Okay, so then first we are going to see how many different ways to access the one table, a table. Okay. This is the relational algebra expression. How can you access the employee table? Using social security number is equal to 1, 2, 3, 4. What will be the bestest way to access this data? You can. Social security number is the unique, right? There will be. This is the problem actually. So we didn't discuss yet about the index. Okay. Actually, we should have discussed the index first. Unfortunately, if I discuss the index first, you cannot have enough time to finish your project B. So that's the reason I exchanged the schedule because of that. However, you understand what is the index, right? So we can use something different structure to access data very fast, even though we do not know how the index structure is organized. We will see later. It's okay. So we can use the index for the social security number. Why? Because the social security number is a unique. Unique means it's the best way to find the data. If we can sort the data by the social security number. So this is one of the ways. And another way is we can find the data, department data, is using inequality. So we can return all the data after the bigger than department number 5 and something like that. So we have the different ways of accessing the data. We will see one by one. First one is linear search. Linear search means when we have this is a naive and easiest way to access the data. So let's say this is a table, an employee table. No matter, so it's not matter whether this is the ordered, this is the sorted, this is the index, whatever. Just read the data, access the data, line by line, tuple by tuple from beginning to end. It's called the linear search. Sometimes it's called a full table scan because you need to access all entire table to find the data. Okay? Or sometimes it's called a brute force way. This is the naive way, general way to access the data. Is it fast? How fast? In case the data is number of n. It's n. Actually, n over 2.
Why?
Why?
More gas.
Why is the n over 2?
It's,
If you are lucky,
oh yeah.
you will find the data at the first
That's
time,
the worst case, yeah.
right? If you are not lucky like me, it will be the last one. On average,
And divide by
just
two.
n over 2, right? It makes sense. So it's the overall n over 2 time, okay? So that is the linear search. Then binary search, everybody knows, based on my experience, what is a binary search. What is a binary search?
It's a binary search.
It's a binary search.
It's a binary search. It's fast.
What is a binary search?
The structure must be sorted.
I'm not sure. Anyone? Binary search. Yes.
The structure must be sorted,
Sorted. Yes.
and then, for example, you take like a pivot or a point inside the array, which is the middle, and then you compare. Is it like is it less or greater than the thing that you want?
Go ahead.
If it's less, then you go to the left part, and then you go to the middle as well, and then you compare. If it's
Okay.
not, you go to the right part, and then you compare it the same way.
I can explain very quickly and simply and the easiest way. So I'd like to find page 128. Okay. So if we are using the linear search from beginning, check. This is page number 37, 39, 30, 41 until 137. Or, so cut in half. This is the 695. So less than 695. So I don't have to check the other and check in the middle. It's a 311. Okay, give up the other. Then this is the 117. So I don't have to. So cut in half always. Okay, cut in half. This is the 161. So this and 149, 133, 137. Okay, this is a binary search, right? And what is the average time to access the? But it should be sorted. That is a different. Linear search, it doesn't matter. Okay, whether or not it's sorted, but for the binary search, it should be sorted. Okay, then what is the time, average time to
Log n.
access binary search? That is the log n. Okay, so based on 2. So whenever you see something binary, it should be the log, something complexity or the average time and something like that in the computational theory. Okay, so that is a binary search. Benefit is a fast, right? Comparing to this is a linear, but this is a huge difference. If you can make any linear, the algorithm to the logarithm algorithm, you will be rich, definitely. So that is the binary search. Okay, the next way is the primary index or hash key to retrieve the single record, which means, so this table, employee table is not sorted, okay? But it has a unique attribute that is a social security number. So we have social security number sorted. Then point the data, okay? This is the primary index. Also, you can use the hash key. Later, I will explain details about the hash key, okay, during the indexing structure. Okay, this is the using primary index. So at the time, we don't have to use the table directly. Instead, we can find the key first. Then using the pointer, this is a pointer to the table where there is the data. Okay, this is another way to access the data.
But this will be only efficient when you want to retrieve only single record. not multiple records.
We cannot say which one is the faster. Okay? For example, do you think the binary search is always faster than linear search?
It depends, no?
It depends. It depends on what?
On how many data you have.
How many data? Okay? That is the reason, even though I erase, by considering statistical information, we need to check which one will be faster. Okay? By considering the number of data or organization of the table, so we need to find one of the fastest way. We will learn the details, how can we select. But before that, you should understand how many different types of accessing the one table. So far, we have 3 different ways. But sometimes we need to access a multiple record, multiple data, so which means if data are sorted, so from the social security number 5, then after that, okay? That is different from the single record, okay? Why? Because 5, 6, 7, whenever you access the next data, you need to find this one, and using this pointer, there might be IO, 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 okay? So anyway, this is possible. So to address that one, we can use the clustering index. Clustering index means this index is one for each record, one for each record, one for each record. What about index by department number, DN, 1, 2, 3, 4, 5. And this one has many records. Employee 111, 222, 3, 112, 223, 22, or 1, 3, 3, 5, something like that. Each key has many records, like your textbook. If you take a look at the index of your textbook, for example, the ODB SQL, it has a 355, so 600 multiple pages. Okay, just like that. So you can have the index that has the multiple. That is called the clustering index. So we can access the multiple record using clustering index. Then secondary, yes.
Can you just repeat for this, like the fourth one for the multiple records?
Multiple record is an index.
It has one index for
Yes.
3, 1
So
record.
this is for example social security number. 1 is Lee, and 2 is James, and 3 is Patel. Okay, but this information is not here.
Yeah.
Then this is Lee is here, James is here, Patel is here. So it's a point like this.
So what's the difference between that one and the third one with the primary index?
This is one record. This is one record. This is a multiple record. Okay. It's the same the structure, but it depends on how many records you need to access. Okay. It can be considered separately. So which means exactly same query. In where condition, ID is 1 or ID is inequality. That's totally different the way to access the data. Okay? Mostly in this case, the linear, the brute force way is faster than index. Okay. The next one is the secondary index. The secondary index is we already have the primary index and the S3 and S4. Primary index for the primary key. Okay, that is sorted. That is guaranteed as a unique data. So we can just sort the data. What if I want the additional index for the candidate key? So, for example, in employee table, this is an index. Primary index is for the social security number. The primary key of this one is sorted. I need another index for the employee ID. Okay, this one is not the primary key but candidate key, so we can make another index, the secondary index. For the secondary index, we cannot. Also, it doesn't have to be the unique data. for example, name or the other, the department number. So at that time, we can make the index. Not just the sorting, we need to reorganize such a data that we don't discuss yet. So that is actually called the B3 index. So we will see later, okay, this one. So 99% of the indexing structure used in the relational database management system are based on B3 index, actually. So you can, actually this one is just a sorted data, sorted data and sorted data, but this one is a different indexing structure. We will see details later, but this one is the second. We can use such a indexing structure. Conjunctive selection is combined. Sometimes it has the ID and social security number is a primary key. So what if they are combined? That is a conjunctive. So conjunctive using composite index is such a index is, so for example, this is a social security number, this is ID. Is there any index combined? If you combine the index is existed, so we can use that one. So that is the next one, conjunctive with the composite index.